In the previous session, we have looked at the gamma function and we have looked at some of the, let's say, identities. Gamma of n plus 1 is equal to n times gamma of n. Gamma of n plus 1 is equal to n factorial. Gamma of 0 is infinity and gamma of 1 is equal to 1. Now, what about negative n's? Let's see. Gamma of minus n is equal to the integral 0 to infinity of x to the power of minus n minus 1 times e to the power of minus x dx, where n is greater than 0. Remember, this n, if it is negative, then minus times minus will become plus. So to avoid that, we are saying n is greater than 0. Okay. So we take out the minus sign. So we get x to the power of minus n plus 1. This we can write it as 1 by x to the power of n plus 1 times 1 by e to the power of x dx. As x goes to 0 from the positive side, e to the power of x goes to 1. So the integrand behaves like integral 0 to infinity of 1 by x to the power of n plus 1 dx at the lower limit. So integral from 0 to infinity of 1 by x to the power of n plus 1 dx is equal to minus 1 by n times x to the power of n from 0 to infinity. Now here again, as x goes to 0 from the positive side, nx to the power of n goes to 0, which means minus 1 by n times x to the power of n goes to minus infinity. Hence the integral near 0 diverges. So which means gamma of minus n is undefined for n in the set of positive integers. So that is one additional piece of information that we have gleaned. Now let's look at gamma of 1 by 2. Let's figure out what this value is. So we apply the integral form is equal to integral from 0 to infinity of x to the power of half minus 1 times e to the power of minus x dx. So gamma of 1 by 2 is equal to integral from 0 to infinity of x to the power of minus half times e to the power of minus x dx. Now we use substitution method. Let x is equal to t square, which implies dx is equal to 2t dt. Now x to the power of minus half, which is what we have here, is equal to t square to the power of minus half, which means it is equal to t to the power of minus 1. Taking care of the limits, as x goes to 0, we have t goes to 0. As x goes to infinity, t goes to infinity. So our integral gamma of 1 by 2 is equal to integral from 0 to infinity of t to the power of minus 1 times e to the power of minus t squared 2t dt. Now here, let's check. X to the power of minus half is t inverse times. Then we have e to the power of minus x. E to the power of minus x will be e to the power of minus t square. Then dx, which is 2t dt. And the limits remains the same, 0 to infinity. So gamma of 1 by 2 is equal to, now here what is happening, t and t inverse, they are getting cancelled. 2 is a constant, comes out. So we have 2 times the integral 0 to infinity of e to the power of minus t square dt. So let's say I is equal to this integral. Integral has no elementary antiderivative. So what do we do now? Let's take it square. And here we'll use a particular trick. So I square is equal to the integral 0 to infinity of e to the power of minus t square dt times the integral from 0 to infinity of e to the power of minus s square ds. Now here, we are multiplying with the same definite integral. Because remember, in definite integrals, the variable of integration doesn't matter. So what happens next? We combine these. We get integral from 0 to infinity, integral from 0 to infinity of e to the power of minus t square minus s square, which means we can write it as e to the power of minus t square plus s square dt ds. Now again we carry out a substitution. Let t is equal to r cos theta and s is equal to r times sine theta. So what do we get by squaring and adding them up? T square is equal to r square cos square theta, s square is equal to r square sine square theta. Adding them up, we get t square plus s square is equal to r square times sine square theta plus cos square theta. So sine square theta plus cos square theta is 1. So we are left with t square plus s square is equal to r square. Here dt ds becomes r times dr dt. Why? Because we are going from one coordinate system to another. Specifically, we are going from Cartesian coordinates to polar coordinates. So that time the functions will warp, and that factor of warping is r. So we have dt ds is equal to r times dr d theta. And here t is greater than or equal to 0, s is greater than or equal to 0, which implies it is in the first quadrant, which implies that theta is in the interval 0 to pi by 2. So now let's do the substitution. I square is equal to this double integral of r times e to the power of minus r square dr d theta. So let's carefully check. Now here we are doing this substitution with respect to the outer integral. And here 0 to infinity becomes 0 to pi by 2. So we have done the correct substitution here. And then we have e to the power of minus t square plus s square. T square plus s square is r square. So we have e to the power of minus r square. Then we have dt ds. We are substituting it with r times dr d theta. So r times dr d theta. So substitution is correct. Now let's solve the inner integral first. So integral from 0 to infinity of r times e to the power of minus r square dr. So again we carry out substitution. U is equal to r square, which implies du is equal to 2r dr. But we want r dr. So r dr is equal to du by 2. So now substituting it, we get integral from 0 to infinity of e to the power of minus u du by 2. Now here I have not mentioned the change of limits, but when r is 0, u is 0. When r is infinite, u is also infinite. So the limits do not change, which implies here 1 by 2 is a constant. So we take it out. 1 by 2 times the integral 0 to infinity of e to the power of minus u du. And solving that integral, we get 1 by 2 times minus 1 by e to the power of u from 0 to infinity. Taking care of the limits, we get minus 1 by 2 times 0 minus 1, which is equal to 1 by 2. So the inner integral becomes 1 by 2. So now we substitute 1 by 2 into this. So I square is equal to the integral from 0 to pi by 2 of 1 by 2 d theta, which is equal to 1 by 2 times the integral 0 to pi by 2 of d theta, which is equal to 1 by 2 times theta from 0 to pi by 2, which is equal to 1 by 2 times pi by 2 minus 0. and that is pi by 4. So we have got I square now. But what we want is I. So I is equal to square root of pi by 4, which is equal to root pi by 2. Remember, gamma of 1 by 2 is equal to 2 times this integral, which is I. So gamma of 1 by 2 is equal to 2I. So gamma of 1 by 2 is equal to 2 times root pi by 2, which is equal to root pi. So we have arrived at another very important aspect. That is gamma of 1 by 2 is equal to root pi. Let's see what is 1 by 2 factorial. That means a factorial of a fraction. Now using the identity n factorial is equal to gamma of n plus 1. We have 1 by 2 factorial is equal to gamma of 1 by 2 plus 1. And then using the identity gamma of n plus 1 is equal to n times gamma of n, we have gamma of 1 by 2 plus 1 is equal to 1 by 2 times the gamma of 1 by 2. And gamma of 1 by 2 is root pi. So we have 1 by 2 factorial is equal to root pi by 2. This was very easy. Now, it's not that easy in all the cases. So let's look at another example. What about gamma of 3 by 5? Now, here there is no known elementary closed form for gamma of 3 by 5 using pi or radicals. So we are stuck. Or are we really stuck? Again, we use numerical methods. So it has to be computed numerically using the integral definition. So let's do that. Gamma of 3 by 5 is equal to the integral from 0 to infinity of x to the power of 3 by 5 minus 1 times e to the power of minus x dx, which simplifies to x to the power of minus 2 by 5 times e to the power of minus x dx. Now, this particular function looks like this. So here, x to the power of minus 2 by 5 is not defined at x equal to 0. Because remember, it is 1 by x to the power of 2 by 5. That means at x equal to 0, it becomes 1 by 0. So let's look at various parts of this, the domain of this function. When x is between 0 and 1, 0 not included, x to the power of minus 2 by 5 grows as x approaches 0 from the positive side. So it is growing from 1 to 10. The integrand becomes smooth and rapidly decreases. Beyond 10, e to the power of minus x is extremely small. So it contributes almost nothing. What do? We parameterize the limits and in turn basically parameterizing the integral. And we don't continue with the limits 0 to infinity. Because 0 is undefined, we can't take the lower limit as 0. So we take something very close to 0, epsilon. So as epsilon goes to the 0 from the positive side, and upper limit we take it as m. Beyond 10, it is extremely small. So m we can take it as 10. So integral from epsilon to m of x to the power of minus 2 by 5 times e to the power of minus x dx. And this is under a limit where epsilon goes to 0 from the positive side and m goes to infinity. But it goes to infinity, but we can take a smaller value as well. So in this case, we may take m goes to 10. Now we take a Riemann sum because remember, we are interested in this area. Here I have kept the lower limit as 0.001. So it is not 0. Otherwise, we can't get this area. And the upper limit is 10. Now what do? Riemann sum. Remember, we partition this interval into smaller and smaller equal parts. So we use Riemann sums to evaluate the integral over epsilon comma n. So the intervals would be of delta x width. So delta x is equal to m minus epsilon divided by m. And x sub k is equal to epsilon plus k minus 1 by 2 times delta x. So here we are taking midpoint Riemann sum. So gamma of 3 by 5 is equal to limit as n goes to infinity. What happened to epsilon and m limits? We basically fix it. We decide specific values of epsilon and m. Once we have fixed it, we just take n to infinity. That is the number of partitions. We take it to infinity. Of summation of k is equal to 1 to n of x to the x sub k to the power of minus 2 by 5 times e to the power of minus x sub k times delta x. Now, as n goes to infinity, what happens to delta x? It goes to 0 because the width gets smaller and smaller and smaller. And as we go to infinity, it becomes 0. So the Riemann sum becomes equal to limit as epsilon goes to 0 from the positive side, m goes to infinity of integral epsilon to m of x to the power of minus 2 by 5 times e to the power of minus x dx. Since as n goes to infinity, delta x goes to 0. This, we don't really do it by hand. We don't evaluate it by hand, this Riemann sum. We use a calculator or a software. If we do that, we get a value of 1.462769 dot dot dot. So that was gamma function. So here, of course, we didn't use gamma function, but I just wanted to show you that if you are asked to find the gamma of 3 by 5 or something similar, then it may not be as easy as we think. Now, if you found this useful, don't hesitate to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now. Bye.